Hello, my name is Bogdan Iancu, and I am the founder of the OpenSIPS project. For me, this is the first time speaking at a TAD Summit event, and also the first time having an online presentation. So I would like to thank you, Alan, for organizing this great event, and also for giving me the opportunity to introduce OpenSIPS to the TAD Summit Asia 2020. I will start talking about what OpenSIPS is. Shortly said, OpenSIPS is a multi-purpose scalable SIP server. It is a multi-purpose SIP server because OpenSIPS has a quite powerful scripting language, which allows you to 100% control the behavior of OpenSIPS, making it act as an SBC, as an load balancer, trunking system, as a generic soft switch, or a virtual PBX system, call center, and so on. So whatever service logic you have, you can go and using the scripting language, you can configure OpenSIPS to do it. In the same time, OpenSIPS is a very scalable SIP server. It is able to handle hundreds of thousands of concurrent calls, thousands of calls per second, and everything with a quite small, reasonable hardware or resources footprint. All this make OpenSIPS a very used SIP server. Many companies, many providers are more and more opting to use open source because yes, the OpenSIPS project is an open source project, so they are opting to use open source when implementing their platforms. If it's to judge based on how much traffic it's daily handled by all the OpenSIPS instances in the world, I would say that OpenSIPS is one of the most used softwares out there when it comes to SIP traffic. So we have a quite powerful relation with the industry. There are many, as I said, companies and providers using us. And even if we are an open source project and it's very difficult for us to keep track of all our users, we encourage the people to say yes, hey, I'm here and I'm using OpenSIPS in our services. So on our website we have a form and listing in the same time, where whoever company is using OpenSIPS can list itself over there. As you see, we have quite a long list. Not to mention some big names like bandwidth.com, Vonage, OnSIP, Twilio, all of them using OpenSIPS in their systems or platforms. So again, we have a quite strong relation with the industry, with our community, and we do that by listening to the needs of our users, to see exactly what they would need in order to make more complex services or be more competitive on the market. So besides helping our community by mailing list, forums, and other mechanisms, we also organize in different shapes events or polls in order to again listen to what the community needs from OpenSIPS. We have OpenSIPS Summit event. We have in different stages of development polls to interact with our community. But at the end of the day, I would say OpenSIPS is a heavily driven by industry in terms of development path. OpenSIPS started like under this name like 10 years ago, more than 10 years ago, and even if it started as mainly as an SIP proxy, during the years we added a lot of features for routing, prefix-based routing, call dispatching, load-based routing, and so on. Features, AAA-oriented features, authentication, accounting, and so on. Different database backends, clustering support, simple presence support like presence and messaging. Different features for call control and so on, but all these features were still in the area of a SIP proxy. Nevertheless, during the years we said, okay, we should move also into the class 5 area. So we already developed an back-to-back support. So OpenSIPS can act also as a back-to-back user agent, not necessarily as a proxy. We have also a call center support, which allows call queuing and distribution to agents. So these are features which are not longer, let's say, proxy-oriented, but more like class 5 oriented. By this process of listening to the needs of our users, we got the feedback that these class 5 features are more and more needed into the OpenSIPS deployments, because at the end of the day, OpenSIPS is programmable, is scalable. So people are looking into providing more and more features also in terms of class 5 systems. So with the last in the last polling, so when determining what should be the subject for the next OpenSIPS release, we decided to heavily focus on the class 5 features. The next OpenSIPS release, 3.1 major release, which will happen probably in around 1 month from now, has a heavy focus on the class 5, or how to do complex call handling. Again, from some perspectives, we still want to as much as possible to keep the calls at the proxy level, so not to do a full back-to-back, but in the same time we want to be able to implement more and more class 5 features like call pickup, call transfer, parking, and so on. These are the features which are the most needed at this time by our community. So the 3.1 philosophy is about complex call crafting. Again, the idea is how to make possible the creation of class 5 features, but without actually turning OpenSIPS into a full back-to-back, because in that area we already have a free switch asterisk, and there is no sense to do an overlapping. We want to do mainly an SIP proxy, which is able to provide the full spectrum of SIP services. So what will be present in the OpenSIPS 3.1 release? I would start with the most relevant features, because there are many of them. Some of them are quite low level from technical perspective, so a bit difficult to understand. But again, I would focus on the most relevant ones. The most important is the calling API. Basically, we want to enrich the OpenSIPS ecosystem, because in the OpenSIPS project we don't have only OpenSIPS itself. We have other pieces of software like the OpenSIPS control panel web interface. We have the OpenSIPS CLI and command line tool. And now we want to add this calling API daemon, an extension to the OpenSIPS ecosystem that will allow through various APIs to place calls and monitor calls through OpenSIPS. Basically, you can use OpenSIPS as a calling engine without actually interacting by SIP. So you can make OpenSIPS to start calls, to answer calls, or to terminate calls. Even more, you can do on hold with a call, so basically muting, or call transfers through these APIs. We do not want to have through this API to have actually an endpoint interacting with OpenSIPS. You will control through the API the existing devices that you have. So assumable you have a device on your desk, and instead of working directly with the device, let's say through a web interface connected to the OpenSIPS calling API, you can trigger the calls on your phone, on your existing phone. You can answer, terminate calls, transfer call, and so on. So this API, the intention of this API is to help you in controlling your existing SIP device. So at the end of the day, even if you have the simplest possible SIP device, which is able just to provide audio support, you can use it as a full, let's say, class 5 feature device through the API, because all the class 5 features are provided through the API for this kind of phones. Another important feature that will be present in the 3.1 release is the call media bridging. There are many features, class 5 features, which require media interaction, and OpenSIPS is purely about SIP signaling. So OpenSIPS itself has no media capability. But again, we want to address a lot of scenarios, like injecting announcements in the calls, or recording ongoing calls. So we want to address such scenarios with OpenSIPS. For that, we use external media servers. So some applications which are able to do RTP playback or RTP recording, and we are interacting with these media servers in order to stream or play RTP into existing calls into OpenSIPS. So in a typical example, Alice talking to Bob, so it's a regular proxy call through OpenSIPS. If we want to inject a call, let's say to Bob in this call, we create from OpenSIPS a completely new call to a media server, just to grab the RTP of the playback, and then through reinvites we inject the playback RTP into the Alice to Bob call. So basically the call between Alice and Bob, it's not affected in terms of signaling. We just take the RTP from a different call, an helper call, and we inject this RTP into the call. Similar, we can do the call recording. So again, Alice is talking to Bob. We can create a separate helper call sorry, for creating a copy of the RTP between Alice and Bob, and to send it to the media server for recording purposes. In a very similar way, we have the SIP-REC module, which implements a SIP-REC client for recording purposes, but this call media bridging support, or the media exchanger module, it's more generic. It's able to interact with, again, whatever SIP media server in order to inject or record the RTP for the calls going through OpenSIPS. Other interesting features in the 3.1 release will be the DTMF support. Again, OpenSIPS is just about SIP signaling, and probably in 95% of the cases, the DTMFs are part of the RTP stream, either directly into the audio channel or as a separate stream at the RTP level, but nevertheless are at the RTP level. So a great addition to OpenSIPS would be to get access to the ongoing DTMF during a call, because based on the DTMF, with access to the DTMF, you can control the behavior of an existing call. For example, you can start or pause a recording, or by pressing some keys, you can inject an playback, an announcement for the other party of the call, and so on. Or even more, you can simulate the behavior of an IVR by combining the capturing of the DTMFs of the call with the feature I already mentioned, with this call media bridging. So all the time when you press a new key, some new audio will be injected into the call. So you have all these features, and thanks to the programmability of OpenSIPS, to the scripting language, you can combine them and achieve a quite wide range of services. Going back to the DTMF support, again, you can even create authentication services. So once the call is up, you can play back, okay, introduce a PIN number, and with the DTMF you can read what was inserted before granting the call access. For getting the access to the RTP level, for extracting the DTMFs, OpenSIPS can interact with the RTP proxy or with the RTP engine. There are two separate softwares, which are mainly RTP relays, and they are able to communicate, or actually the other way around. OpenSIPS is actually able to communicate with the RTP proxy and RTP engine in order to extract a different kind of information from the RTP stream, like the DTMFs in this case. Another class 5 extension, interesting extension in the 3.1 release, is the extended BLF support. The BLF is quite useful because by this mechanism, people in SIPS systems can monitor the calling status of a different person. Basically, whenever I make a call, automatically, my status will change. I'm in the call, or my phone is ringing, or the call was terminated, so I am available. So basically, the BLF support allows you to share the dialogue status between the users in the system. And this BLF, it's not used only, for people to know if somebody else is talking or not, but actually it's used in other class 5 more complex features. For example, in call parking, you can monitor the BLF status of a parking slot to see if it's used or not. Or when you do call, let's say call pickup, you can see which are the ringing extensions by BLF. So providing the dialogue status of users or different kind of resources in the system, it's very, very useful for the more complex class 5. And we said, okay, we need to improve a lot the BLF support provided by OpenSIPS, just to make it a good foundation for building more class 5 features on top of it. And for the 3.1 release, the actual let's say limitations we addressed with the BLF were the ability to properly publish dialogue information in scenarios like call forking, parallel and serial forking. So where the parties involved in the call are changing, or there are multiple callee parties, like in the parallel forking. So there was basically a complete refurbishing of this BLF support, just to make a more detailed publishing of the dialogue status for the calls going through OpenSIPS. Now, another interesting thing that we are working for the 3.1, I mentioned already that we have a back-to-back support, so actually OpenSIPS can work as a full SIP back-to-back user agent. And the main work we did here is about clustering. OpenSIPS has a very powerful clustering engine which allows you to hook together multiple OpenSIPS instances in order to achieve either high availability, either geo distribution and failover. So the ability of OpenSIPS to replicate in real time all the runtime data across the cluster, it's something very, very useful. We already have these abilities for user registrations, for ongoing calls, for presence data and so on. But starting with the 3.1, we added this in-cluster replication of runtime data also for the back-to-back engine. Basically, that means you can start a back-to-back session on one server, and if that server crashes, and you can instantly take over and continue with a call on a completely separate OpenSIPS instance. You don't need to restart anything. It's, again, the replication, it's real time. You have it already there, and it works. That's a perfect usage example in combination with Anycast. So one OpenSIPS goes down, traffic is diverted to a different Anycast node, which is fully in sync in terms of what are the back-to-back sessions with the original node. Also, in the back-to-back area, to make it more programmable and to be able to implement more and more scenarios, back-to-back scenarios. We are working to add a back-to-back context, so you can attach different kind of custom data to the back-to-back scenario, and you can control it during the progress of the scenarios. For example, in call center applications, scenarios where again the call center is basically based on the back-to-back, and we need to attach different kind of custom information about the calls before we queue them. So this information may be later pushed to the agents when the call is delivered. And because we mentioned the call center, also in 3.1 there is a lot of work we did for the call center, like increasing the support for call dissuading with different thresholds, like number of calls in the queue, or the average waiting time, or what was the duration of the waiting in the queue. So all these thresholds may trigger a call dissuading. Also, to make it more easy to use for the agents, the 3.1 version of OpenSIPS introduced the ability to play pre-call announcements to the agents in the call center. Because an agent can serve multiple queues in the same time, it means it may receive calls from different queues, so with different properties. So with this pre-call announcement, we have a playback to the agent, notifying the agent about the nature of the call he is about to receive. More or less for the same purpose, we have in 3.1 call center events. So whenever changes something about the call delivery, we fire events which may be consumed by external application, external to OpenSIPS, like by web portals. So the agent can see on the web portal a lot of information about the call he is about to receive. So everything is about increasing the let's say the agent experience in such call center scenarios. The last but not the least, we have in 3.1 steer and shaken support. There are a lot of big discussions in the US, in the telco world, about fighting against robocalls, about CLI spoofing and all this. And the steer and shaken support was introduced as a mechanism to fight against something like that. So we developed. I think we are one of the first open source SIP stacks providing steer and shaken support. And we did a lot of tests. We even participated to the SIPNOC 2019 with this implementation to see how it will fit, to talk to the providers, to the SIP operators, how they want to implement this steer and shaken support in the infrastructure, and to be sure that the implementation in OpenSIPS is able to provide all the support they need in steer and shaken implementation. Besides the steer and shaken, we have also the DFKS, the device feature key synchronization, which is something really cool. It's about keeping in sync the settings of a feature between multiple devices that you may have and the application server. As an example, you have a D&D button on your phone, and when you press that the button on the phone will start rejecting the incoming calls. In the same time, your SIP server may offer a D&D on server feature. So basically, the server will reject all the calls that you may receive. So you see, this D&D do not disturb service may be controlled and implemented into locations, SIP servers and phone. With the DFKS support, these two are aggregated and synchronized, meaning that both the phones and the SIP server are keeping a single state, and they are offering a single point of controlling this do not disturb. Basically, the phone, when you press the D&D button, it's talking to the SIP server through presence, saying, okay, this feature is now enabled, so the SIP server will start rejecting the call. So basically, the phones synchronize with the SIP server in terms of the status of certain features. Similar to the D&D, you have the call forward settings, which may be synchronized between the SIP server and the phone. So all these features are typical class 5 oriented features. Nevertheless, the 3.1 brings some, let's say, under the hood features like the push notification support. And yes, finally, the IETF brought the RFC 8599 last year, which is the standardized push notification for SIP servers. And yes, the 3.1 OpenSIPS will provide a full implementation, the full support for this RFC. So far, there were like, all the bits and pieces over there in order to implement the push notification, but each SIP device may have its own, let's say, understanding on how push notification should work, like how to wake up, how to register, and so on. So again, thanks to this RFC, now we have a standard way of doing it for all the devices. The RFC already includes the push notification support for Apple and for Android. So all applications running on Android and iOS will benefit from this standard push notification support. This is again what we plan and what we are working for the 3.1 release. And as I mentioned, we are interacting a lot with the community, and maybe we are not all the time as verbose as the community wants, but we try as much as possible to listen to the needs and to the feedback from the community. And this also happens when we plan the releases. When we have a release plan, we go back to the community with polls saying, okay, what should be the priority, or what features are of an interest for you? And we have here at the end of this planning page, what was the result for the community poll for the 3.1 release. We have these scores over here telling us, okay, from the community perspective, which are the most interesting features, and we are trying to address according the feature implementation according to these priorities. The work on the class 5 features, and also all the proxying capabilities which already exists in OpenSIPS makes OpenSIPS a powerful open source candidate when it comes to implementing implementing SIP infrastructures or SIP services. And this is something that we noticed also for the Asia area. There are more and more companies adopting open source and OpenSIPS as a candidate for replacing the hardware or appliance-based existing infrastructure. So switching to software and open source software for SBCs, for balancers, for edge proxies, and so on. So whatever they had as hardware before, again, we see this trend of replacing with software and open source software, and of course with OpenSIPS more and more. Nevertheless, it's what we notice. It's not only replacing existing infrastructure, but also building more complex services, and that means multi-tenant PBX and virtual hosted PBX systems. As you know, businesses are emerging. Their need for more complex communication is, obvious. So the operators or the VoIP providers are looking to offer this class 5 or PBX oriented features, which with a full range of features. And that's one of the reasons why we are focusing this 3.1 release in OpenSIPS to the class 5 features, because again, we want to make OpenSIPS one of the best candidates when it comes to picking up an open source software for building the SIP and SIP infrastructures or SIP services. Well, we will see in less than 1 month when the 3.1 beta release will be available. If you follow our web page, the opensips.org web page, we have the news sections where a lot of technical blogs are listed, a lot of news are listed over there. So you can stay tuned with all the news or progress we do. So I think I hope I managed to give you an overview of what OpenSIPS is and what OpenSIPS roadmap is, so you can consider OpenSIPS as a viable component for whatever SIP VoIP plans you have. And yes, we hope to be up to the challenge. Again, thank you for participating to the TAD Summit Asia, and I hope the information I provided was useful, and hopefully we will see again to another TAD Summit event. Thank you.